this diagram and we're going to take a look at the given information. So if you did that worksheet last night, you're used to having information given to you and marking your own diagram. We've done that already. So what does it give me? And this is really, I need you to watch me do this and I'm going to go back through it again because it's a complicated process. So it says that WZ, so let's go find that, WZ is perpendicular to YX. Okay, hold on, my computer's a piece of trash. Okay, YX. So those two lines are perpendicular. So I immediately can, kind of deduce some things. Oh God, this is so frustrating. Okay, I'm good. That means where these two lines meet, right angles are created. Okay, so I'm going to go ahead and draw those on the diagram. I'm going to erase my little visual aids there. So WZ is perpendicular to YX, and so that's why I made those markings. Okay. Then it says segment WZ is an angle bisector. And we talked about before we went to lunch that an angle bisector cuts an angle into two pieces. So it bisects this whole angle up here. So that means that 3 and 4 are equal, okay, because that's the two pieces that it's cut into. So I'll go ahead and make those markings. And then there's one more mark that I can make based on a couple of theorems that we've talked about. And that's the shared side, right? So right here I can mark WZ congruent to WZ. I'm going to use 3 because I've already used 1 and 2. I'm actually going to use 2 marks up here. The 1 mark has already been used. Okay. So after I took all my given information, it says angle 1 and angle 2 are congruent, right? Angle 1 and angle 2 are equal. How do I know that? Right, but how do I know that?
They're side by side.
Right. We have to do something else first. So look, 1 and 2 are 90-degree angles. Okay, we marked that on the diagram, right? How do I know they're 90-degree angles?
They have the
Perpendicular. I heard it. Good job. This is the definition of a perpendicular line. That is how I know. That is what told me to mark those as right angles. This right here. That telling me that those lines are perpendicular and me interpreting that to understand that those make 90-degree angles. Okay? Angle 1 is congruent to angle 2. Why? Because all right angles are congruent. Is that true? Are all right angles congruent to each other?
No.
Yep.
Yeah.
Yeah.
Yes, because let's think about what congruent means. It means same measure, right? All right angles are 90 degrees, so they're all obviously going to be congruent to one another. Angle 3, yes ma'am.
Oh.
Angle 3 is congruent to which angle?
4.
Angle 4. How did I know that? How did I make those marks? What told me? What was my justification for making these? Do you remember? The bisector.
Yeah.
This is the definition of a bisector. The word bisect told me to do that because I know that a bisector means this. But they told me that, remember? It's an angle bisector, and that's what prompted me to make these markings. Okay? So notice how I'm providing a specific justification for everything I did. Segment WZ is congruent to what other segment?
ZW.
ZW or WZ. What do we call that? What's the math name for that? Starts with an R. Reflexive. The reflexive property. So again, this is just me asking you that. Why did you know how to make that mark? And you providing the answer. I know because that is the reflexive property of congruence, that a segment is congruent to itself. And then finally, triangle WZY is congruent to which other
WZX.
No, W,
WZX. Because
because it's Z at the end.
yeah, because look, the W's have to match, the Z's have to match. What is my justification for two triangles being congruent? It's one of those five. In this case,
Sass.
one of the five theorems.
Then why do you say size?
You can say any because I've marked all the sides. Notice I've got all sides congruent, all angles congruent, so any one of the five will work. Okay, so we just wrote a proof up here. This is a proof. Okay? I showed that all of the angles had a congruent match. All of the sides had a congruent match. I had to show 6 things to establish this statement. 3 sets of angles, 3 sets of sides, and then I was able to say about the triangles. Okay, you can close that.
Alright.
All right, so what are the reasons we can mark congruent sides? Well, one of them is that, the information is given to us, but we can also do this with a bisector. We can do it with the reflexive property, or we can do it because we have a midpoint. Okay, those are the 3 reasons, other than that it's given to you, that you can give me for marking a side. And if you can't justify with one of those 3 ideas, then you don't get to mark that side. Okay. Reason we can mark angles, we can have an angle bisector. Or, what was my other word I put there? Oh, and we're going to use vertical angles. We have another, or vertical. Okay. So if we are proving that congruent sides are angles, you have to prove those triangles congruent using one of your reasons: SSS, SAS, ASA, AAS, or HL. Okay? I'm going to do several of these with you today, and then you're going to do something. Okie dokie. So let's head to our first proof. This is number 5. So step number 1, mark.
Wait, what was last? Recent one?
What was the third one?
ASS.
Okay, they're up on the board. The 1, 2, 3, 4, 5. They're written in marker on the board.
The last reason.
Oh. Bisector, reflexive property, or midpoint. And bisector or midpoint. All right.
Put the last, like.
The last reason.
It says and then.
The last
The last
reason.
one, the proof.
Oh, I was like, the last reason of the proof will be one of these. I didn't know what you were talking about. I was like, what do you mean the last
And then when you
reason?
started reading like the bicycle,
I was like, what is she doing?
I don't know why I did that.
They're just keeping you straight.
I know, I'm like, they're paying attention. That's good. Will be one of those reasons, okay? So the first step, number 1, mark the given information on the diagram. So the first thing it gives me is segment AB is congruent to segment ED. So you notice your homework last night is just kind of a step right below this, and then we're adding more to it. So, okay, that one has been marked. Then we're going to mark BC congruent to DC. That one's been marked. And then I'm going to mark that angle B is congruent to angle D.
Wait, what about AC and CD?
Those are not equal. Nothing. Can you give me one of the reasons that I gave you earlier? And does it say in the given information that those things are equal?
Oh.
No, that's just something that we are assuming, and we can't do that, okay? So you have a statements and the reason. This is the why. So the first statement, I'm going to write all my givens. So the first statement I'm making is I'm like, hey, AB is congruent to ED. Why do I know that?
Because it gives us-
Because it is given to me. There you go. Given. So that's all we write there. Why do I know that? Because they told me. Okay, let's write the second statement. BC is congruent to DC.
Given.
Given. The third given statement, angle B congruent to angle D. How do I know? Given. These are going to be your favorite ones. So the givens are written first, and then always in this part is the prove statement. So notice in every prove it says prove this. What you're trying to show, and you can't, like that's not true until you show me it's true. I'm asking you to show me that. That triangle ABC is congruent to EDC, and how you do that is by establishing one of these theorems. Side, angle, side. So this is my first side, this is my angle, and this is my side. I've got it all done, right? I've checked off everything. So now I can conclude, write my prove statement here, just copy it down. Triangle ABC congruent to triangle EDC. How do I know that?
SAS.
SAS.
This is easy.
Good.
This house when we go on.
This is, number one is the easiest one.
Okay.
Now, the way you go back and check your work here to make sure that you've done everything is if I'm trying to show SAS, I have to make sure that I've shown all three of those things, sides, angles, sides, earlier in the proof. Did I show a pair of sides?
Yes.
Yes.
Then I showed another pair of sides.
Yes.
Then I showed the pair of angles. So I have established the S, the A, and the S here, here, and here. Okay?
Yes.
You have to make sure that you show all components of what theorem you're using. Let's do number 6. I don't like the way that's lined up. Okay. Remember what I said. The first thing you need to do is mark your diagram. Angle W is congruent to angle C. Segment WA is congruent to CA. So I'm going to mark my given, and then I'm going to mark, vertical angles, shared sides, etc. Are there any vertical angles here?
Yes.
Yes, we're going to mark those. And it looks like I've got ASA, right? All right. Now let's write ASA here. I have to do it one at a time. Okay, I'm trying to prove this by angle, side, angle. So I've got to do that by showing a pair of angles, a pair of sides, and a pair of angles. So the first one is angle W congruent to angle C. How do I know that?
Given.
Gives us.
Given. Then I'm going to go segment WA congruent to segment CA.
Given.
Given. Now, I have an angle and I have a side. What do I need one more of?
Another angle.
I need another pair of angles to make ASA. So that's these. So I need to write that down.
Angle A.
WAP.
PAW.
Okay, yep.
PAW.
Paul.
PAW is congruent to angle MAC.
That one's
Yeah, sounds good. How did I know this?
because
Given.
No, it was not given.
vertical angle.
Vertical angles, good. I made those marks right here not because it was in the given statements, because I know vertical angles are congruent. That is the justification for that. These marks were given by this, and these marks were given, oh, that's bad.
Mac.
So, let's see, angle W, angle C. This gave me these two. This given statement gave me this and this, and then the vertical angle theorem told me to do this. What goes here?
The
Triangle Paul.
The prove statement, yeah, the triangle Paul is congruent to triangle Mac, right? This goes there. This is the prove statement every time, and this is the 5 theorems every time.
put on